Hey guys, welcome back to another Kubernetes video. Today we will be talking about role-based access control. In a prior video we looked at authorization from a high-level view and a number of different authorization mechanisms. One of those was role-based access control, and since role-based access control is probably the most prevalent method of authorization in Kubernetes, we'll now look at it in detail. So, what does role-based access control allow us to do? It allows us to create a role for a specific set of users, for example, developers. And the role contains a set of permissions, and then we associate the user or set of users with that role. And if a change is needed, we simply modify the role. As we mentioned in the other video about authorization, attribute-based access control is another method. However, in order to modify any of the policies in attribute-based access control, we have to restart the Kube API server, which is not ideal. That is not the case with role-based access control, so it is quite a maintainable solution to authorization. Now, before we get into the actual structure of how to set up role-based access control and the format of our YAML files and so on, we need to look at the Kubernetes API and how different resources are grouped. So first of all, at the root of the Kubernetes API, we have two different paths that need to be taken into consideration. The first one is /API. It's not actually listed here, but in /API we have all of the core resource types, the original resource types that were provided with the first version of Kubernetes. For example, things like pods, services, the fundamentals of a Kubernetes cluster are under /API. However, in /APIs, this is where more recent and more advanced resources were developed and placed in terms of the API. So with /APIs, all of our different resources are grouped. So we have apps, extensions, networking, and so on. And under those groups, we have deployments, replica sets, stateful sets, different types of resources that belong to the group. And for each of the resources, there are different verbs. And these verbs are simply the actions that we can perform on the resources. Now, the verbs do not vary from, using /APIs versus using /API. And the concept of resources is also the same, but it's just worth understanding that groups are not present in /API, and we'll look at how that manifests in roles as we go forward. So, what is a role? It is used to provide namespace access, and some of the key fields are API groups, resources, and verbs, as we kind of looked at in the previous slide. First of all, just to recap, a role allows us to specify a set of resources that an action can be performed on, or a set of actions can be performed on. In this case, our API groups is actually an empty list. What does that mean? That means that there is no group for this particular resource, which means it is under the /API, aka all the original components that were first deployed with early Kubernetes. And the reason we're using that is because we want to specify a role for pods, and pods are obviously the fundamental resource in Kubernetes. Then we specify the verbs get, watch, and list. So this essentially gives us read access to pods, this particular role. Now we have defined the role, but we haven't defined what users are going to have that role and what users will be assigned the privileges that we have defined within the role. And this is where role binding comes in. It is used to map a user or a group to a role, and some of the key fields are subjects and role ref. Under subjects, we can see the type of subject, in this case it's a user, the name of the user, and then the API group of that kind. So it's generally RBAC.authorization.kubernetes.io. Second is a role ref, and this is where we refer back to the role that we previously defined. So the important field here really is name, because it mentions the name of the role that we defined up here, pod reader. Also, the kind obviously is role, and again the API group is that RBAC.authorization.kubernetes.io. Now, in our previous examples, we showed you how to set up a role and a role binding. Roles and role bindings are namespace. So in that previous example, if we look at this, the read permissions that we have granted in the role are only relevant to the default namespace. If we want to give cluster-wide access to a resource, then we have to use a cluster role. So it is used to provide cluster-wide access and provide access to non-namespace objects. So things like nodes, certificate signing requests, and persistent volumes. And then in order to map the cluster role to a particular set of users, we use a cluster role binding, and this essentially operates the same as a role binding, but at the cluster level. As I said, associate a cluster role with users, groups, or service accounts. And that is our video on role-based access control. Hope that was useful. If you have any questions, please leave a comment. I'll get straight back to you. Please like and subscribe, and I will talk to you in the next video.